All right, first thing is rotations. Do we remember clockwise? Which direction is clockwise?
This way.
To the right. Clockwise is to the right. So 90 clockwise, how many quadrants does that move it? One quadrant to the right. But 90 clockwise is the same as 270 counterclockwise. So this is 1 to the right for 90. How many to the left?
3.
3 to the left for 270. The rule is you change the sign of the X and switch the order. So if I'm looking at this, what would my A prime be? 370. All right. If it's 90 counterclockwise, well, that's 1 to the left, or 270 clockwise, which is 3 to the right. You change the sign of the Y and swap the order. So this would be
2, -3.
And if it's 180, change the signs but do not swap positions. So this would be A2. Just swap the signs and you're good on the 180. All right, one thing that they almost always have on the EOC is this. Rotational symmetry is when you can turn it and it still looks the same at the end. So if I took this one right here, the pentagon, and said, how many degrees could I turn it and it still look exactly the same?
360.
You say 360 divided by 5. Where's that 5 coming from?
The sides.
However many sides or angles, for that matter, that you have. All right, so I have 360 divided by 5 is 72. That means I could turn it 72 degrees and it would still look the same. However, they will not give you 72 as a choice. What you have to do is take this 72 and multiply by 2, multiply by 3, multiply by 4, and however much until you get back to 360.
What the?
All right.
You said multiply by 2.
Take 72 times 2, 72 times 3, 72 times 4. All right. But they will not use the 72 and they will not use the 360. Your answer will come from in there. It'll be one of those 3, most likely. If we had a hexagon, well, how many sides do I have? 6. So I would do 360 divided by 6. That's 60 degrees. So then I would say 120, 180, 240, 300, 360. You're not going to use the 60. You're not going to use the 360. Your answer would come from one of those. So if it's talking about rotational symmetry, that's what they're going to look at, is those. All right. What they're going to do on this, and hopefully Friday we'll look at it more, it's going to say what combination of translations, reflections, rotations will map it back to itself. In other words, you're going to do 3 or 4 things. Does it wind up where it started at? So all you got to do is go through those changes and see if it goes back to the original. And hopefully Friday we'll look at more of those. All right, scale factor stuff for dilations. If it is bigger than 1, what happens?
It's larger.
It's bigger. If it's 1, stays the same. If it's between 0 and 1,
smaller.
Normally when it's on this one, last one, we'll say it's a what? What does it look like? This number. If it's between 0 and 1.
Fraction.
Normally we want to say it looks like a fraction. It is a fraction. The problem with saying that is, what about 3/2?
That's more than 1.
That's going to go right there. So that's why it's important to say between 0 and 1 before it gets smaller. How can I look at this right here and say that figure 2 is or is not a dilation of figure 1?
Times by 2.
Can I take figure 1 and multiply it by something to get figure 2? If you can, there's your scale factor and it's a dilation. If you can't, then it doesn't. What about figure 3 compared to figure 1?
No.
Yes.
Oh, wait, compared to figure. Yes.
All right. Most people see it dividing by 2, but I don't need the division part. I need the multiplication part. Dividing by 2 is the same thing as multiplying by
1/2.
1/2. If I divide by 3, that's multiplying by
1/3.
1/3. Divide by 4 is multiplied by 1/4, and so on. What if it gives you 2 figures right there, and it says in this case it's figure 2 a dilation of figure 1?
Just multiply it on the.
Yeah.
How do I determine if it's going to work?
You gotta get
write out
the
the
points.
points.
And And you have to write down.
Is figure 2 a dilation of figure 1? So I start with figure 1, write down my points, then go to figure 2, write down the points, and then say, can I take the first one and multiply it by something and get the second?
Yes.
In this case, the scale factor would be 2. Something else you're going to probably be asked is, what is the center of the dilation? In order to find the center of the dilation, you take the points that match up, whether it's A and A prime or whatever, and draw a line through them. And do that for all 3. Wherever they hit, that's the center of the dilation right there. Now, this one is 0, 0. I'd be willing to bet the one on the EOC is not going to be 0, 0. It'll be somewhere else. But that's what you do. You draw the lines through the points that match up, and you find the center. All right, if it's similar triangles, how do I solve that? Or any similar figure for that matter?
This one.
No.
It was 6, right?
No.
It's the 6, the small.
Set up the proportions. Now, could you do the 4 and 8 stuff? Yes. The problem is, what are you going to do on this one? Because now it's not going to divide evenly and all that. So set up the proportions, cross multiply and solve. If I'm doing this one, I would do something like x over 5 and 6 over 4. You've got to be able to do that right there. What would I need to do on the first one over there?
Make sure the angles are in the same spot.
I'm going to rotate it, reflect it, something, so that my angles are in the same spot. Well, in this case, I needed to rotate it. So that means the 4 comes to the side, the 10 goes here, the 8 goes up top. So what would my proportion be that I need to set up there?
X over 10, and then either 4 over 10 or 8 over 20. I think I
disagree.
said that wrong.
If I said x over 10, then I've got to do 10 over 4 or 20 over 8. Whichever one you start with, you got to start with every time.
I see 25.
So in this case, if I start at x over 10, I've got to do the 10 over 4 or the 20 over 8. Can we do scale factor to find area? What's the scale factor right here? 5. You would say 30 divided by 6. You always do the second triangle divided by the first triangle. So the scale factor is 5. But in every area problem we ever do, we square stuff. So that means the area of the second one is 25 times bigger than the area of the first one. The area of the first one is 20 times 25. That would tell me the answer for the second one, the area of the second one. What's the scale factor right there? First one. What? 1/4. Why is it 1/4? Second divided by the first. What happened to the triangle? It got smaller. The only way it can get smaller is if the scale factor is between 0 and 1. What would I do with that 1/4? Square it, you get 1/16. Then do the first area times that to get the answer. It'd be 4. These right here, y'all, we should get every one of these right. What do I do on this?
You make a building or like a triangle.
Do 2 triangles. Most of the time they're going to have the triangles drawn for you and the numbers already in there. All you got to do is work it out. 300 foot tall would have to go there. 47 foot shadow would go there. How long would the shadow be? 22 foot tall tree. What is my proportion?
X over 47 and 22 over 300.
I hope somebody said that.
Is that wrong again?
300 over 22 and 47 over x. If I start with the big triangle first in the top, it's got to be in the top on the second. The only time that we would not have the height going straight up and down is when? If it says something about it falling or leaning, then it could be the hypotenuse. Otherwise, height is going to be straight up and down. All right. Similar triangles, you have 3 rules. Angle, angle. Now this is different than the congruent stuff we did the other day on the proofs. Angle, angle. If 2 angles match, the triangles are similar. Go back, what does similar mean? Same shape, different size. Similar is same shape, different size. So if you have two angles the same, the triangles are the same as far as similar figures go. Side, 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 we got to set up the fractions and see if those work out to be the same. Side, angle, side, check the side, see if they work, and then check the angle if it's in the right spot. What rule, or why would this be angle, angle?
Because it's two angles.
I've got the two angles matching. But really, if I have two angles matching, what do I actually have?
Another angle.
A.
But if I have two, what do I really have? If this is 50 and this is 60, well, that means that one's 50 and that one's 60.
So really you have three.
What's the missing one?
The 90.
What? No, it looks like a 90, but based on 50 and 60,
Oh yeah.
that would be 70 and 70. So if you have two angles the same, you really have all three being the same. And a lot of times they like to do questions like this. They'll say, if angle F is 50, angle E is 60, what is angle A? Well, angle A is in the other triangle, but what are we supposed to know? If these two match those two, then the third one has to match also. So you just figure out what the third one is over here, 70, and it will match the other side. All right, on side, 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 you're checking do the fractions match up. How do I check the fractions? Does anybody remember?
Is it you
No, what?
plug it in? It'd be 10 over 8 and
Nope.
nope.
Small, small, middle, middle, big, big. Go from the second one back to the first one. If you go from the second back to the first, and they all work out to be the same, there's your scale factor. Right? Which is more important on one like this bottom one. Small, small, middle, middle, big, big. Well, 6 is the small, 4 is the small. 9,
Whoa,
6, 12, 8. Way easier to set it up if you go small, small, middle, middle, big, big, instead of worrying about trying to rotate and all that. Right? If it's side, angle, side, what did I tell y'all to check first?
Angle.
Is the angle in the right spot? Because if the angle's not in the right spot, nothing else matters. Right? So, is the angle in the right spot?
No.
It's not?
Yeah.
If it's in between the sides, it is. Here's my two sides.
Oh, outside.
Angle's in between. There's my two sides. Angle in between. So that works. Then I'm going to check small, small, big, big. If I get the same number, yes, it's similar. All right? What would the first rule? Angle, angle. I've got two pairs of angles that match. What about number 2?
Side, side, side.
Are we sure?
No.
How do we check it?
Do the wait.
Small, small, middle, middle, big, big. See if it works.
Yeah, it is. Because
So small is 10 over 5. That's 2. Middle is 16 over 8. That's 2. 20 over 10 is 2. So yes, that one works. 3.
no, it's nothing.
What's wrong with it?
This angle. The angle.
That angle is not in the right spot, so that throws it out. I'm not looking at the sides. Number 4,
Side, angle, side.
the angle's in the right spot. 5 over 10 is 1/2. 7.5 over 15 is 1/2. So that one would work. What would I do on number 5 right here?
The two separate triangles.
2 triangles. So I do my small triangle, which is 6, 7, and 9. I do the big triangle. I know that's 14. What is the bottom? And then check that. 14 over 7, 12 over 6, or actually 12 over 6, 14 over 7, 18 over 9. See if you get the same thing. What do I have to do right here?
You got a ABC. No, you got a minus 25 by the 6 and all that. And get that X.
All right, well, I'm hoping we do this.
Oh wait, I take that back.
The question is, how much is this part right here?
X minus 25. I mean,
That's what
25 minus X. Why is it 25 minus X and not X minus 25?
Because it's the whole thing.
The whole side is 25. If it gives you the whole side, you do the whole thing minus the part. So it's got to be 25 minus x. And then I would say, well, 25 over 25 minus x equals 10 over 6. Do your cross multiplying and all that. Pythagorean theorem, I hope we're good on.
That's
The only thing that's important, really, is C. C has to go by itself. So which one is my C right there?
X.
So this 8 and 15, those can switch, doesn't matter. The X has to go in the C spot. Which one is my C right there? 34. So 34 has to go over here. These can switch. Do what now? The biggest number has to be the C. And that's important for what we're about to look at. How would that, I know which one. Well, let's do this.
Whoa.
Well, how do I know if it just gave me 3 numbers? Well, let's do this first. How would I check this one right here?
A squared, 12 squared plus 16 squared equals 20 squared.
I'm going to put the 20 in the C spot.
Because
See if you get the same number on both sides. If you do, it's a right triangle. If you don't, it's not. Say I gave you these numbers. 15, 8, and 17 and said, is it a right triangle?
Yes.
How do you check it?
A squared plus 15 squared.
17 has to be the hypotenuse. And then the 8 and the 15 don't matter. And if that works out, then it works. If you can remember these right here, that would probably help you out. Make things easier. Where do the other numbers come from? Like the 6, 8, 10, 9, 12, 15? Take those and start multiplying. 3 times 2, 4 times 2, 5 times 2. 3 times 3, 4 times 3, 5 times 3. All right, we've already talked about the parallel line stuff with the proofs of the day. We understand corresponding, I hope.
Yep.
Consecutive interior or consecutive exterior. Sometimes they'll call it same side interior, same side exterior, same stuff. Alternate interior, alternate exterior. We're good on those. Basically, it boils down to this. If they look the same, they are the same. All the acute ones are going to match. All the obtuse ones are going to match. Now, if I said what is 1 and 3, we should automatically know that's corresponding. 5 and 6.
5 and 6. Linear pair.
Linear pair. 5 and 8.
5 and 8. Consecutive exterior.
Consecutive exterior. The problem is they're probably not going to ask you that straight out. What they're probably going to do is give you a proof and say, well, angle 2 is equal to angle 7. So what is my rule right there in that proof?
Angle 2, angle 7, alternate interior.
You would say alternate interior. That's probably how they're going to ask it. It's inside of a proof. That's the way they've done it in the past. So it's the same stuff we've been doing. Don't let it be in a proof mess you up. Look at it and see what it is, and then answer the proof. Any problems with matching these up? Same deal. If it looks the same, it is the same. All the acutes match, all the obtuse match. What about here? You only got 2 choices. Either set them equal to each other or add them up equal to 180. What would I do on the first one over there?
Equal each other.
Equal to each other because they look the same. They're both obtuse. What would I do here?
Equal 180.
The second one, I'd add up to 180 because those are consecutive. All right? The proof stuff. All right. If you have a parallel line inside of a triangle, it cuts the triangle so that you can set up the proportion stuff. How would I set up this first one right here?
8 over 8, X over 8.
Say again?
8 over 8.
All right, if I do 12 over x, then I would have to do 10 over 8. There's your fraction line right there. The parallel line makes the fractions for you. If I start with 12 over x, then I've got to go back and do 10 over 8. But I could start, if I did 8 over 10, well then what would I do next?
8 over 12.
I have to do x over 12. What would I do on that top, or first one over there, on the top part?
You can do X over 8.
I can do x over 11.
Then 25 over 10.
Nope.
No, then you got 15 over 10.
Remember, if it gives you the whole side, do the whole thing minus the part that they give you. What would this part be right here?
X, 25 minus X.
25 minus X. What would I need to do on that first one right there?
X minus, I mean,
You have to get one of those sides in.
I'm going to do two triangles. My little triangle would be Y, 5 and 10. This would be 30. How much is the left side of the big triangle?
16 plus
16 plus Y, or Y plus 16, whichever way you want to do it. And then this would be 5 plus 8,
5
or
plus.
8 plus 5.
Oh, yeah.
If it gives you the two pieces, you add them up. If it gives you the whole thing in one of the pieces, you subtract. And then after that, you would do the proportion stuff. What would I do here?
Make two triangles.
Two triangles. All right, now that's the problem. I can't do Z plus X. So I need to figure out what X is first. What is X?
5.
Hopefully
3,
we
4, 5.
recognize it's a 3, 4, 5. If you don't recognize it's a 3, 4, 5, do Pythagorean theorem. So now I know that's 5, which means that's a 5, and then I can start doing the proportion. All right, the congruent stuff, we've already done this with the proofs. Side, 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 angle, side, angle, side, angle, and angle, angle, side. What would number 1 be?
Angle side.
Angle, side, angle. Number 2,
Side, angle side.
side, angle, side. 3,
Angle side.
angle, angle, side, because the side is not in between. And 4, side, 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 when I mark the middle.
Side, side.
Now, what they're probably going to give you is this right here, where they say, what is the missing piece of information to make whatever rule work? They give me the angle, so that's taken care of. What else is already common? That side right there is good, so I'm missing the third side. Where would it have to be? It would have to be right there and right there. So what did I just mark? BC would have to be equal to CD. What about number 2? Mark the middle, so that takes care of one side. They give me the top and bottom, that's another side.
PM equals over.
I'm obviously missing the other one, that's got to be PM equals. Okay.
I thought that to like for BC, I thought it would have to be like BC or something. I thought it would let us have to be side. Like if that one had to
Sides you can do you can switch the order, it doesn't matter.
This is what angles would do.
Angles you can switch, like if I wanted to talk about this right here, I could say BCA or ACB, that's the same thing.
Okay.
What about the third one over here? What's missing? The side. I already got both of the angles, but the side cannot be where?
In between.
Can't be in between, so that
It'd be
right there would not work.
It'd be RT and CE.
So if I choose that, I could say RT equals CE, or
R equals DC.
I could say RS equals DC. Either one of those choices would work. All right. The right triangle one's the only one that's important. Hypotenuse leg, because it's not like the others. So that's the only one we need to have out of this group. What would the first one be?
Angle side.
No,
side.
no.
Wait.
Side and angle.
What is that X in the middle?
That's
That's the hypotenuse. And what else is marked?
That's
That's the hypotenuse leg. We need to be able to identify that now. That's the one we've got to know. So here, what is the missing information for hypotenuse leg? Well, what is BD? That's my hypotenuse. So I'm missing
The
the
leg.
leg, which could be
BC.
AB equals CD or AD equals BC. Either one of those
Anything.
choices will work. All right, proofs. Hopefully we've done enough to get some proof points. All right, if you're classifying triangles by the angles, acute has 3 acute, obtuse has 1 obtuse, right has 1 right, equal angular means all of them are 60 degrees. So equal angular, all of them are 60. If it's by the sides, scaling, no sides are the same. Isosceles is 2 sides are the same. equilateral is all three the same. Now, isosceles, that's what it looks like. We've got two sides the same. You need to realize if you've got two sides the same, you also have two angles the same. Now, they may ask, how do you prove that those are the same? Can anybody, if I had this right here, and it said, given isosceles triangle ABC, prove angle A equals angle C. Can anybody tell me?
AB equals BC.
But look at what it's asking me to prove. An angle is equal to an angle. So what would that last rule need to be? The CPCTC. In order to have CPCTC, what has to happen before that?
The angle side.
I got to have some triangles the same. I only have one triangle. So what do I need to do probably?
Make a new one.
Make another one.
Oh wow, that was so easy.
So I would draw in BD. Remember how we did the drawing in on the other one? So I would say draw BD perpendicular to AC. Why do I need it to be perpendicular? What does that make it?
Right angles.
So now I can say I've got right angles. And then what else can I say?
It's got a
So
side.
AD equals DC. Oh. Yeah.
And
I
then
can
you
say
already got
BD
one
equals
side.
BD because of
Reflexive.
reflexive, and now the triangles are the same because of. Why are those triangles?
Side angle side.
Nope.
Bisected.
Hypotenuse legs.
Oh,
And if
yeah.
the triangles are the same, then I can say A equals C because of CPCTC. So. Another thing on equilateral, that means the sides are the same. If the sides are the same,
Angles are the
then
same.
the angles are the same. All right, this right here, there may be one or two questions. What you need to remember, if you can, centroid is the medians, orthocenter uses altitudes, in-center uses angle bisectors, circumcenter uses perpendicular bisectors. If you can just remember those, you might can get a question or two right. All right, hopefully we remember the parts of a circle.
Yes, sir.
Radius goes halfway across, diameter goes all the way across, chord starts and stops on the circle, secant goes through the circle and is a line. Tangent can be a segment like it is there, it can be a ray, or it can be a line. How many times does it touch the circle?
Once.
Just once. The only way a line can be tangent to the radius is if it's perpendicular. So how would I determine if that's perpendicular or not? Pythagorean theorem. If I do Pythagorean theorem and it works, that means it's a right angle. If it's a right angle, it's a right triangle, which means it is perpendicular. What would I need to remember on this one?
Radius is always the same.
Every radius is the same, so then my whole side up there would be 13. These, all you got to remember is they have to be equal. Pythagorean theorem would be that right there. Do we remember how to do that part?
Yeah. The part they highlighted?
Yep.
Yeah, you can do r squared or r plus 4 times, or I think, or plus, I'm not sure. R plus 4.
We would do r plus 4 times r plus 4. Full method. That's going to be r squared plus 4r plus 4r plus 16. There is the shortcut. Obviously, we don't remember it. 4 times 2 is what?
Hey.
That goes in the middle. 4 times 4 is?
16.
That goes at the end. What's going to happen on the next part? R squareds cancel. You're left with a simple equation to solve after that. Central angles, arcs, semicircle. The 2 minor arcs on the left, 2 major arcs on the right. Hopefully we're good there. If it gives you 2 letters, which way do you have to go? The shortest, closest way you can go. CB and BC are the same exact thing. Right? But if it gives you 3 letters, you have to go in the order that they give them to you. So like ZVY, I have to go this way for that. What do we need to do on something like this? Fill in all the stuff you can. Vertical is 55 there. I can use that right there as a semicircle at the bottom. Add those up and subtract to get that one. Same thing on the top, 55 is there, so 125 will be there. And since all of those are central angles, then all of them are going to match the outside. And then it's just a matter of adding them up. A, B, and CD, are they the same?
Yes.
Two things you got to check. Is it the same circle or congruent circles, and all the numbers the same? One circle means that part's good. Vertical angles, they match. What about number 2? They're not the same. Circles are different sizes, don't work. Automatic wrong. Alright, here, the chords are the same, the arcs are the same. If the arcs are the same, the chords are the same. This one is probably more important. If it goes through the center and makes a right angle, it cuts this one in half and it cuts that one in half. This one, if they're the same distance from the center, the chords are going to be the same. What would I do on something like this? What would I do? Set them equal to each other. Solve it, and then what? Take that number and plug it back in. So this would be 4 times 16, which is 64. 80 minus 16, which is 64. Those should be equal when you get done. If they're not, you did something wrong over here. How would I find CD then? What would I do for that?
CD, that's 64 minus 180.
You know that's a semicircle up top. You can do the 180 and solve that. All right, this part right here, some of us messed up the first time. If it's a central angle, what does it do for the outside part? It's the same. So if this is an 80, that's an 80. But if it's an inscribed angle, which means it goes to the circle and then comes back out, the angle is half the arc. The arc has to be twice as much. So if I'm looking at this first one, what's my next one?
100.
That's going to be 100. Here, I would divide by 2 and get 95. The third one, that's 100, so this would be.
200.
The problem is,
What the one that you gotta do the whole thing? Like, it's more than that, it's more to it than that. It's like a triangle and a circle.
right, so here, it would really be 360 minus the 200 and get 160. Make sure you answer the question that they asked, because that's more like what they would do than just a straightforward question. So here, I'm going to multiply that by 2, I'm going to divide that one by 2. But again, RQ is this part. So I'd have to do the 180 to find that one. Which ones are the same over there?
A and B and C and D.
These two are going to match, A and B. Those two are going to match C and D. If I see a diameter, what does that automatically tell me about that? You got to have a right angle. If I see a right angle, then what does that mean?
That's 180.
You got to have a diameter. It's got to be 180. This part right here, we messed up both times we did it, the first time and the retest. The rule is, the only way I can put a quadrilateral inside a circle and all the points touch is if the opposite ones are supplementary. Which means what?
But end up to 180.
Add up to be 180. Is it the same?
Oh, sorry. My-
Add up to be 180 and the same are not the same. That's why we messed it up the first time. Opposite ones add up to be 180. So what would I do here? Two X plus 104 equals 180. Do not put them equal to each other. 3y plus 6y equals 180. What do we do on these?
Fill it in.
Fill in the outside part first. What would this part be?
62.
No, sir.
Subtract 180 from
Do 180 minus the
Oh
123.
yeah.
And do 180 minus the 62. Then you check. If it's an arc, it goes out around the circle on the outside. If it's an angle, it goes inside. And the easy way to figure out, is it a central angle or an inscribed angle, is this. What is the center of my circle?
Hey.
If A is in the center of the circle and the center of the angle, it's a central angle. So BAC, that's a central angle. Answer is
123.
123. However, if I go over here, now E is in the center. So what kind of angle is that going to be?
It's concept or something.
Inscribed.
Describe.
BEC is inscribed. So it's not going to be 123, it's going to be 123 divided by 2. That would be the 61.5. So you got to determine, is it central or is it inscribed? And you do that based off the letters. This rule, angle is half the arc. So angle 1 is half of AB. Angle 2, half of BCA. Here, the angle is half of the first arc that it makes and the one that's vertical. Angle 2 would be BD and AC. Right here, it's half of the big one minus the little one. And it has to be in between the lines. Half of the big minus the little in between. PQR, PR. And then this one, XY, and WZ. What would my answer there be for angle 1? What would I do? Divide by 2? 66. What would I do here? Multiply by 2. What would I do to find angle X right here?
Divide by 2.
No.
70.
You would do half of 140 plus 112.
Oh.
And then type that in the calculator.
Okay.
These are the ones that we can do the shortcut on, if we remember it. The angle has
It's
to
in the
be
middle. It's
halfway in between
I remember.
those two.
Oh yeah.
So 64 is 9 lower than 73.
Be 67.
That would have to be 9 higher.
No.
Or you could say the angle is half of 64 plus x. What did I tell y'all to do on that problem right there? First thing. Nope.
73, 1/2, maybe. Oh yeah.
Multiply both sides by 2. That just multiplies out. Those cancel each other out. And it leaves what's in the parentheses. And then you just solve what's left. These, half of the big one minus the little one. Well, the little one is right here. So how would I find it? This part right here. How would I find it?
What is that 180? You have to add up all the circle.
So that would be 288.
And then subtract by
360 minus 288 leaves 72. That would go in there. Same process over here. I'm going to do half of the big one, which I would have to figure out what that one is, doing 92 plus 30 plus 112, and then say whatever that EA is minus the 30. If it gives me the angle is half of the big minus the little. What did we say about solving those? What do I need to do first? Multiply both sides by 2, so that's going to be 86. 2 cancels that. Add it across and you got your answer.